Fourier series representation. Okay. So we will try to do this one. Okay. Actually, this kind of question will not come to exam. Okay. So I will briefly tell you how to do this anyway. Okay. So this one, I think this one, anyone can do this one. Okay. Because here, if you plot cos 5 by 4n. So here you are not given n values, okay? So that means n from minus infinity to plus infinity, okay? So if you draw the signal, okay? So you know that cos signal will look like this, okay? The continuous cos signal will look like this, okay? And what you have to do is, you have to find the samples when n is equal to 0. N is equal to 0, cos 0, so that will be here, this sample, okay? It will be here one sample. Then n is 1, that is 5 by 4. Okay. So let's say that n is 2, that is 5 by 2. So the 5 by 2 value is here. 5 by 4 value is somewhat here. Okay. So you can use a calculator. So you have to find what is cos 5 by 4 value. Cos 45 here. Cos 45 කියන්නේ පොඩ බලන්න හරි. මොකක් හරි value එකක් එක්ක. ඒකට මූල දෙකයි නේ. ඒකට මූල දෙකයි වෙන්නේ. 1 over √2 මෙන්න ඇති. හරි. සම්බපාදි වෙන්න කාර්යය. එකයි මේකෙන් √2. ඔව්. ඒකට √2 වෙනවා. මෙතන වැලියු එක. ඊළඟට ආපහු මෙතන n equal to n equal 3 here minus ඒකට √2 minus 1 over √2 here 0 1 2 3 4 n4 is 5. So here this value. Likewise you can find the sample value. Okay. Then in this direction also you can find the sample value. Okay. Then you can find the, so this is repetitive signal. Okay. So you have to find the repetitive, the sample, the n naught. Okay. So the n naught will be, you can see that this sample will be maybe let's say that this sample will be repeated after this one, this one, this one, then this one. I will draw it again. Okay, so normal cos signal will look like this. Okay. Okay. Cos signal will look like this. Okay. So cos n is equal to 0, cos 0, that is this point. Okay. N is equal to 1, that is 5 by 4. So you will get this one. Okay. So the value is around 0.0. 0.7 value. Okay. That is n is equal to 1. Okay. N is equal to 2. The value will be 0. N is equal to 3. Again, value will be minus around 0. Minus 0.5. 0, 1, 2, 3. Okay. And 4 will be here. Okay. 5 again will be here. Okay. This is 5. Okay. And 6 will be here. 7 will be here. 8 will be here again. Okay. So this is the 8 value. Okay. So this is repeating here. Okay. This is the 8 value. Okay. So you have to count the sample, number of sample from here to here. So you have 1, 2, 3, 4, 5, 6, 7, 8. Okay. So here for this side, for this signal, n naught is 8. Okay. So you have to find Ck value, that is K from 0 to 7. That means 0, C0, C1, C2 up to C7. 7. Okay. So you have to find this value. Okay. So in the same manner, you can use the identity and you can find this. Okay. So if you consider this one, okay, actually this kind of question, it is hard to draw by hand. Okay. මේ වගේ signal එක අතින් අඳින ටිකක් අමාරුයි. You have to use MATLAB to draw this signal. Okay. MATLAB use කරලා මේක ඇඳ ගන්න using MATLAB. Okay. The procedure is you can, so this is a cos signal and this is a cos signal. So you can find the cos signal. You can substitute some value to n, 0, 1, 2, 3, likewise. Then you can find the cos value. Then you can plot the cos term like this. Then also in the same manner, you can find the sine signal also. You have to add, you have to substitute the n values, 0, 1, 2, so on. You can find that value also. Then you can add them together. Okay. If you are doing it manually. Okay. So this is also can be done in manually, but it is somewhat hard. So using MATLAB, maybe you can easily draw this. Okay. Actually, this one also, it is better to use MATLAB to draw. Okay. But the same procedure here also. Okay. So what you have to do is the simple way is, okay. So you can select some n value. Let's say that n you are selecting from -8 to +8 or something, -8, -7, -6, 0, 1, 2, 3, 4, like this. Okay. So you can add some n value here. For example, if you consider -8, you have cos square 5/8 -8. Okay. So you can find this value using a calculator. So that is the value for n is equal to -8. You can find that value using a calculator. In the same manner, you can add -7 here. Then you can find the value -8, -6, you can find the value. So on, you can find some value. Then you can plot it. Okay. You can plot it. Then after plotting, okay, after plotting, you can see the repetitiveness. You can check the repetitiveness. Without plotting, it is hard to guess how the signal is repeating. Okay. So after plotting, you can repeat it. You can find it. Okay. For example, if I use MATLAB, give me a moment. Okay. තේරෙනවද කියපේක? මෙතන n වලට වැලියු දාලා මෙතන cos වැලියු හොයාගන්න පුළුවන් cos එකට n 8 يعني ඔයා කැමති ගානක් සිලෙක්ට් කරගන්න. ඍණ 8 10 ඍණ 10 ඉඳන් ධන 10ට හරි මොකක් හරි වැලියු ටිකක් සිලෙක්ට් කරගෙන ඒ වැලියු ආදේශ කරලා අර සාමාන්‍යයෙන් අපි ඉස්සර ප්‍රස්ථාර අඳින්නේ. හරි? අත වශයෙන් යට වශයෙන් අපි ප්‍රස්ථාර අඳින්නේ. මෙයා තමයි ඉන්ඩිපෙන්ඩන්ට් වේරියබල් එකට එයාට වැලියු දාලා එන වැලියු එක හොයාගන්න කැල්කියුලේටර් එකකින්. හරි? එතකොට ඔයාට n එනවා මොනවා හරි වැලියු ටිකක්. හරි? n වලට මොනවා හරි වැලියු ටිකක් එනවා. n වලට මොනවා හරි වැලියු ටිකක් එනවා. ඒ වැලියු වලට අදාළ xn වැලියු ටික හොයාගන්න පුළුවන්. හරි? එතකොට ඔයාට xn උත් එක්ක හරි xn එක්ක n plot කරන්න තියෙන්නේ. මේ වැලියු ටික මාක් කරගන්න තියෙන්නේ. කොයි හරි විදිහකට එනවා වැලියු ටික. හරි? ඒ වැලියු ටික මාක් කරගෙන දැන් plot කරන්න ගියොත් plot කරනවා කියන්නේ අපි ඔක යා කරනවා මෙහෙම. එහෙම යා කරන්නේ නැහැ මේකෙදි. ඒ වැලියු ටික විතරක් තියාගන්න. හරි? තියාගෙන ඒකේ බලන්න ඕන කොයි පොයින්ට් එකකින් ඉඳන් කොයි පොයින්ට් එකකටද රිපීට් වෙන්නේ කියලා. හරි? ඒක තමයි සාමාන්‍යයෙන් කරන්න ඕන කට්ටිය. මේ වගේ එකක් එක්සෑම් එකට එන්න බය වෙන්න එපා. හරි. මොකද මේ වගේම අතින් අඳින්න අමාරුයි අත්තට. මේකින්ද මේ වගේ එකක් එක්සෑම් එකට එන්නේ නැහැ. picture එකක් කරන්න තියෙන්නේ. හරි. In the normal manner, okay, you are selecting some n value. Okay, so you can select some n value. Okay, let's say that you are going to take n from -10 to -10 to the increment will be 1 to +10. Okay, so these are n values. Okay, okay, these are the n values. Okay, so if you run this, you can get some n values here. Okay, -10, -9, likewise. Okay, so these are the n values, the independent variable value. හරි, මේ තමයි independent variable value එක. දැන් ඔය කට්ටියගේ signal එක දීලා තියෙනවා xn. හරි, xn දීලා තියෙනවා. xn is given as cos, okay, cos 5 by cos square. Okay, 5 by 8. Okay, 5 by 8 n. Right? Cos square 5 by 8 10. Okay, so this is 5 by 8. Okay, multiplication n. Okay, so this is, and you have to get the square. Okay, you have to get the square of this whole term. Okay, so I will write this. Okay, so this is cos square 5 by 8 10. Okay, so what you now have to do is, now you have to add this n value to this one and calculate the xn value. Okay, so MATLAB will calculate it. Okay, okay, so MATLAB will calculate it. Okay, and you will get some xn value. Okay, so these are the xn value. So this one related with the -10, this one related with the -9, this one related with -8, so on. Okay, so these are the value. Now you have to mark the value, but you don't dot. Okay, dot means you have to join each point. එහෙමනේ අපි ප්‍රස්තාරය යන්නේ point එකෙන් point එකට join කරලා. හැබැයි මේකෙදී අපි අඳින්නේ point එකෙන් point එකට මේව කරන්නේ අපි signal එක තියා ගන්නවා හැමෝම. ඒකට පාවිච්චි කරන stem command එක. Stem independent variable එක x, dependent variable එක x minus n. Okay, okay, so this kind of question one you will get. හරි, මේ වගේ එකක් තමයි ඔකට එන්නේ. දැන් බලන්න මේක repeat වෙන එක ඔයා බලන්න ඕනේ. දැන් බලන්න මෙයාව repeat වෙලා තියෙන්නේ මෙතනනේ. This one is repeating here, this one is repeating here. So you can select any repeating point. මම මෙයා y තෝරා ගන්නවා. තෝරාගෙන කරන්න තියෙන count කරන එක. දැන් මෙතන ඉඳන් මෙතෙන්ට ඔන්න count කරනවා. count කරන්න පුළුවන් 1යි 2යි 3යි 4යි 5යි 6යි 7යි 8යි. Okay, so in this signal also n not is equal to 8. Right? Same manner you can draw this signal. Okay, MATLAB වලින් අන්දාත් calculator එකෙන් ගොනත් පුළුවන්. හරි, ඕන එකක්. So in not you will get 8. So again you have to find from C0 to 7, C7. Okay, so you have to do it like this. Okay, okay, so in this way you can do this question also. Okay, okay, so now I think we will move to the next one. Okay, I think that is enough. So if you need, you can do that question also. Okay, so anyway we will move to the next part. Okay, okay, this one. Okay, so this is, we have to find the Fourier transform, discrete time Fourier transform. So this one for non-periodic signal. Okay, this one for non-periodic signal. Okay, so you have to find the Fourier transform of this signal. Okay, so I hope you can draw this signal and this signal without issue. Okay, you can draw this signal and this signal. Okay, and this one also, it is straightforward. No? This one also you can do. Okay, so this is the zeroth sample. This is the zeroth sample. Okay, and I hope you should be able to now draw this one and this one. Same procedure we use. Okay, so I will maybe we will do this one. Okay, so this is very straightforward. No? So you have the sequence. You are given the sequence. Okay. So the zero sample is marked by arrow, this one. Okay, so try to do this question by yourself. Okay, make question okay. So maybe we will try to do this one, maybe this one. Okay, we will try to do this one. Okay, so okay, so anyway, you have to use the Fourier transform. Okay, for that one. Okay, that is for non-periodic signal. In previous question, we have done Fourier series representation for periodic signal. So this is for non-periodic signal, that is Fourier transform. Okay, and you have this equation. Okay, so these are the equation for Fourier transform. Okay, this is for Fourier transform and this is for inverse Fourier transform. Okay, so if you are given any signal xn sequence, okay, you can convert this sequence. So this is in n. Okay, so you know that n is also related with time. N is equal to a number of sample into t. Okay, so this is the n is also related with the time. Okay, this tn. Okay, time is equal to the number of sample into t. The n sample time is equal to number of sample into t. Okay, so in this way, this n also related with time. Okay, so this is a time dependent signal. The independent variable is time. Actually, the sample number, but sample number is again depend on the time. Hari? Then can sample number එක. හැබැයි sample number එකත් ආපහු time එකේ variable එකක්. හරි? time එකත් එක්ක relate වෙනවා ඒක. මෙන්න මේ විදිහට තමයි relate වෙන්නේ. හරි? එතකොට මෙයා time domain. හරි? So we can convert this time domain into frequency domain, omega domain. This is frequency, omega, angular frequency domain using this identity. Right? So any signal, any non-periodic signal, any signal, you can convert into omega domain using this identity. You have to multiply by e to the power minus j omega n, then you have to find this you have to evaluate this summation, not the integration. Okay, but once you convert this xn into omega domain, හරි මේ n කියන එක omega domain එකට convert කරාට පස්සේ time domain එකට convert කරාට පස්සේ මේ omega කියන එක discrete කියලා අපිට කියන්න බෑ. We can't say that this omega is a discrete value. Omega is actually complex value. So in the inverse Fourier transform, you have to do the integration because this omega is not a discrete value. හරි මේ omega කියන එක discrete value එකක් වෙන්නේ නැති හින්දා ඔය කට්ටියට inverse එක හොයනකොට ඒක integration එක කරන්න වෙනවා. මොකද මෙයා discrete time එකක් නෙමෙයි, මෙයා continuous, මෙයා discrete variable එකක් නෙමෙයි, මෙයා continuous variable එකක් ඉන්නේ. හරි? So you have to familiar with this equation. Very important this one. Okay. In your exam, this one will come, not the inverse Fourier transform. Okay. So you have to using this identity, you can find any Fourier transform. Okay, so we will do one question. Okay, so we will take this one maybe. Okay, so I think you can draw this one very easy. Un minus un minus 1. So you can draw the un signal like this. This is go up to infinity. This is 0, 1, 2, 3, so on. Then you can draw un minus 1. This is shifted signal. Okay. So this 0 is shifted to 2. 1 is shifted to 3. 2 is shifted to 4. So on. You have infinity. Then you have to subtract this one from this one. හරි මෙයාගේ මෙයාම අඩු කරන්න තියෙන්නේ. අඩු කරපුවාම 0 1 වලට එනවා sample 0 වලට එනවා 1 වලට එනවා. මෙතනින් එහාට බිඳුව. හරි එතකොට මෙයා තමයි සිග්නල් එක. හරි මෙයාගේ හරි ලේසියෙන් ඔයාලට හොයන්න පුළුවන් ෆෝරියර් ට්‍රාන්ස්ෆෝර්ම් එක. හරි හරි ඊළඟට frequency spectrum එක හොයන්න කියලා කියනවා. හරි ඒකත් හොයන්න පුළුවන්. මම මේක කියන්නම් හොයන හැටි. අපි හැදුවා මේ වගේ ගණන්. Okay we have done this kind of question. Okay දැන් මෙයාගේ තියෙන ඇත්තටම sample දෙකයි. This one also sorry this is multiplied by 2. So this signal is multiplied by 2. So this will be 2 2. හරි මෙයාගේ දෙකයි එනවා. එතකොට මේ සිග්නල් එකේ තමයි ෆෝරියර් ට්‍රාන්ස්ෆෝර්ම් එක හොයන්න තියෙන්නේ. හරි ලේසි. හරි. දැන් මේ සිග්නල් එක ගත්තොත් එයාගේ සාම්පල් දෙකයි. හරි එයාගේ සාම්පල් දෙකයි තියෙන්නේ. එතකොට එයාගේ තියෙනවා එකක් දෙකයි පළවෙනි සාම්පල් එක දෙක n-2. ඒ කියන්නේ දෙකක් මෙහාට shift වෙලා. ඒ කියන්නේ 1 නෑ 2 මෙහාට shift වෙලා. එතකොට මෙයාගේ සාම්පල් එක එකයි. හරි දෙකයි එකයි. හරි එතකොට මේ දෙකෙන් එකක් අපි හදමු. හරි මේකත් ලේසි. මේකේ ඔය කට්ටියට අඳගත්ත හැකි. අඳගෙන මෙතන නිකන් පොඩි එකතු කිරීම අඩු කිරීමක් කරන්න තියෙන්නේ. හරි. මේ ටික එකතු කරන්න තියෙන්නේ. හරි ලේසියෙන් හොයන්න පුළුවන්. හරි. මේ ටිකම නෙවෙයි එකතු කරන්න තියෙන්නේ. You have to write that exponential terms and you have to add them together, okay? Because there is a sum, okay? So we will try to do this one, okay? Because the frequency spectrum also we can draw using this one. Okay. So we will try to this one. This kind of question you will not ask to draw the frequency spectrum because to draw the frequency spectrum it may be hard for this one because you have to get the whole answer as a one complex number. So there are some mathematical things to do. Right? Mathematics so it is somewhat hard. So maybe this kind of one you will be given to find the frequency spectrum also. Okay. So I will do this one. Okay. I will do this one. So your signal is xn is 2 delta n minus delta n minus 2 or something. Okay. So your signal will look like this 2 delta n. So that is here 2 delta n minus 2 means delta n is shifted by 2 from 0. Okay. So this will be 2. Okay. 1. Okay. And the value will be 1 because it is not weighted. Okay. The value is here 1. Okay. So it is 1. Alright. Make a weight color and signal. Now you have to find the Fourier transform of this signal. To find the Fourier transform, what you have to do? X omega is equal to sigma n from minus infinity to plus infinity xn e to the power minus j omega n. Okay. So this is you have to add. Okay. So very easy. So n from minus infinity to plus infinity. N minus infinity here it will be 0 and 2 to plus infinity it will be 0. So you have to add them from 0 to this one. Okay. 0 to 2. Okay. So n from 0 to 2 xn e to the power minus j omega n. Okay. Very simple. Okay. So this one, if you are going to do this one, මෙයාව හදනවා නම් මෙයාගේ n තියෙනවා ඍණ එකේ ඉඳන් මෙයානේ බිඳුව. හරි මෙයා බිඳුව. හරි so I'm going to give a clue, okay, to do this one. මේ මේක හදන්නේ මෙයා තමයි බිඳුව sample එක. මෙයා එතකොට 1. Yes, do you have any question? Okay, if you have any question, you can ask. Okay, maybe it is a mistake. Okay, 0 and this is 1, this is 2, this is 3, this is 4, 5, 6, 7. Okay, and this is minus 1, minus 2. So you have n from minus 2 to plus 7. Okay, so n you have to do from minus 3 to plus 7 xn e to the power minus j omega n. Okay. So you have to do this expansion. Okay. So xn you are given the xn from -2 to +7. So you have to add them together. Okay, very simple. Alright. Like a lazy theorem. Alright. Now this is also very simple. This is more simple. Okay, because only you have to add only 2 terms. There you have to add 9 terms, no? 9 or 10 terms. Okay. So here it is very easy. Okay. So xn x0 e to the power minus j omega n is 0 plus x1 e to the power minus j omega is 1 plus omega no n is 1 x2 e to the power minus j omega 2. X0 is 2 e to the power j omega is 0 2 plus x1 is 0, so this term will be 0. X2 will be 1 e to the power minus j omega 2. Okay, so x omega you will have 2 plus e to the power minus j omega 2j minus j omega. Okay, so this is x omega. This is the Fourier transform. Okay, x omega is equal to 2 plus e to the power minus j 1. Okay, so you are asked to draw the frequency spectrum. That is, you have to draw x omega. Okay, actually frequency spectrum, you have to draw the magnitude of x omega. Okay, magnitude x omega with respect to omega. Okay, so what you have to do, that you have to find the magnitude of this signal, of this one. Okay, with respect to omega. So how you can find the magnitude here? Okay, so you have to write this as a complex value. Okay, so you have to use the Euler formula here maybe. Okay, මෙතනදී ඔකට Euler formula එක පාවිච්චි කරන්න වෙනවා. Okay, so you can use the Euler formula here. Maybe you can write this as cos e to the power minus j2 omega. Okay, so this is the theta value. Okay, so you can use the Euler formula. So you can write it cos 2 omega minus, because this is minus, sine 2 omega, j sine 2 omega. Okay, so this is the plus value and this is the, so this is the real value and this is the imaginary value. Okay, so you can write the imaginary terms and the real terms and the imaginary terms. Okay, so to find the magnitude of x omega, okay, what you have to do is, okay, to find the magnitude of x omega, you have to find the magnitude. Okay, magnitude is this is square, this term is square plus this term is square. Okay, so you have to find 2 cos omega 2 is square plus sine 2 omega is square root. මට හරියට තේරුන්නේ නැහැ අහන ප්‍රශ්නේ. magnitude එකේ equation එක ගන්න විදිහ magnitude එකේ equation එක ගන්න විදිහ ආපහු කරන්න කියලාද කියන්නේ? magnitude එකේ equation එක ගන්න හැටිද? ඒ කියන්නේ complex number එකද? complex number එකද? complex number එකක් තියෙනවා නම් a plus ib කියලා. මේක තමයි real part එක, මේක තමයි imaginary part එක. This will be the real part and this will be the imaginary part. So the magnitude, you have to get a square plus b square. Square of the real part plus square of the imaginary part, and you have to get the square root. So this is the magnitude of this complex number. Right? The complex number, the magnitude එක මේක. ඒක දැහුවේ. මේ කියපු උත්තරේ හරියද? අහපු එකටද උත්තරේ හම්බුනේ? Did you get the answer? Did you get the answer? You are asking another thing. මේක දැහුවේ නැත්නම් වෙන මොකක් හරි. මේ තමයි කම්ප්ලෙක්ස් නම්බර් එක මැග්නිටියුඩ් එක හොයන්න මෙහෙම. එතකොට මෙතනදිත් කරේ මැග්නිටියුඩ් එක හොයන එක. මේ තමයි රියල් පාර්ට් එක. This is the real part and this is the imaginary part. So I get the real part of and this is the imaginary part. I get it. හයවෙනි ප්‍රශ්නේ කෝකද? හරි හරි ඕකේ. හරි හරි. හයවෙනි එක මම කරගෙන යන්න පොඩ්ඩක්. හරි. Okay, so this is the magnitude. Okay, so you have to find this. So this is somewhat complex. Okay, so maybe MATLAB you can easily plot this. Okay, but anyway, by hand also you can do this. Okay, because you can square this one. Okay, so you will get 4 cos 2 omega plus cos square omega sin square omega. So cos, so you know that cos square theta sin square theta is 1. Okay, so maybe you can use that one. So you will get this kind of one actually, 4 plus 2 cos omega ohm. Okay, once you simplify this. Okay, so then you have to draw the omega with respect to you have to draw x omega with respect to omega. Okay, so maybe it is maybe hard to draw by hand. Using MATLAB you can do that. Okay, so this kind of question will not come to your exam. Okay, so here maybe you will be given this one like this. Okay, delta n minus 1 or something. Okay, so if it is delta n minus 1, here it is not here, at minus 1. Okay, 2 is at minus 1. Okay, so you have two exponential term here. Okay, so using two exponential term, maybe using the Euler formula you can easily find the magnitude. Okay, so we have done that kind of question actually. Okay, so try to do. Okay, for example, I will do it again. Okay, let's say that you have 2 delta n minus 1 plus delta n minus 2. If you are given this kind of signal. Okay, if you are given this kind of signal. Okay, this is n. Okay, so if you are given this kind of signal, so this is n minus 1. N minus 1 means it is, let's say that this is plus 1. Okay, so it is shifting to this direction. So this will be minus 1. So it will be 2 here. Okay, and this is n minus 2. So it will be here plus 2. So it will be 1. Okay, now you can find x omega. Okay, using Fourier transform. Okay, sigma n from minus infinity to plus infinity x n e to the power minus j omega n. Okay, so x omega is equal to n from minus infinity to plus infinity. So here it is minus 2 to plus 2. Okay, so you will have x minus 1 e to the power minus j omega minus 1 plus x0. x0 is 0 here. x1 also 0. Then x2. x2 e to the power minus j omega plus 2. Okay, so you will get this kind of one. Okay, and then you will have x omega. Okay, you will have x omega. X minus 1 is 2 to the power e to the 2 e to the power minus j omega n plus x 2 is 1, x2 is 1, so 1 e to the power minus j omega 2. Okay, maybe this one also may be hard to um, hard to draw, maybe using the Euler formula also. It is maybe hard to draw this one also. Okay, so if this is minus 2, then it will be easy. Okay, if this is minus 2, using the Euler formula, you can do that one. Okay, so this will be plus j2n, and this will be minus j2n. So e to the power plus j2n, e to the power minus j2n, you will get the value e to the power, sorry, using the Euler formula, cos 2 omega plus sine 2 omega, cos 2 omega plus minus sine 2 omega. So sine 2 omega, sine 2 omega, j sine 2 omega, sine 2 omega will cancel out. Then you will get only cos term. Okay, so you will have cos term here only. Okay, so that you can find the actually this one also, the weight also should be equal. Okay, to find that one. Okay, so if you have this kind of one, you can easily find the frequency spectrum. Otherwise it will be somewhat hard. Okay, so don't worry about that. Okay, so if you are asked to plot the spectrum, so that question will be in your level. Okay, so you can simplify it in your level, or we will give a hint for that one. Okay, anyway, is that clear? So I hope we have done this kind of question, so you can do that one, okay, by yourself. Okay, so I will do the next one.